All right, so have a look at the handout that says Semester 1 Exam Debrief. So we'll just go through a few examples together with some discussion from the class. And would appreciate your full attention, so please don't talk during this section. All right, so let's look at example 1. This is like the second part of the second question on the first page. So you started off by finding the gradients, and then you had to use that gradient to find the equation of a line. So first, we are given this form y equals a plus bx, and b is the slope or gradient. If I can find the numbers a and b, then I am done with this question. So what information do we already have here? Yes, gradients here, -3. So now I can write y equals a minus 3x. The key insight here is that b equals -3. Okay, what next?
Substitute the points that we already have.
Okay, and where is that, Noah?
24.
Yeah, so I've got a coordinate here, 24, 10. So when x equals 24, y equals 10. You don't have to write that, but I'm doing it for you in case it's not clear. So now I've substituted x and y into this equation. 10 equals a minus 3 times 24. We don't have time to do this next year. We assume that you know this when you start Year 12 General. So that's why I'm going over it now. And at this point, I've got a minus 72. To get a by itself, because that's what I'm trying to do, I need to add 72 to both sides. 10 plus 72 gives me 82. Now, a big tip for you sitting exams, once you've finished the question, reread the question to make sure you've addressed everything that's been asked for. This asks for an equation. So if you just write a equals 82, you're not finished. You need to write the equation. So the equation is y equals 82 minus 3x. And now you are done. That same advice, of course, applies to any subject, not just maths. Make sure you've addressed what they've asked for. Okay, do we have any questions about example 1? Is that clear enough? Okay. All right, let's look at example 2. This question was very poorly done on the exam. I've just changed the number. .04207. Let's start with 3 decimal places. The first decimal place is here, the second decimal place is here, and the third decimal place is here. So when I write my answer, and this is not the final answer, by the way. When I write my answer, I'm only going to have 3 digits after the decimal points. Now, I also need to look at the next digit. Because if this digit here, the fourth one, is 5 or larger, I need to round up. Here it's not. It's less than 5, so I don't need to round up. My answer is just going to be 0.042. Okay, next one is sig figs. Where is the first significant digit here? 4. This is the first number that gives us information about the size or magnitude of the number. So 4 is the first significant digit or figure. So you'll need to look over your notes from last term. Essentially, the rule is if you have a decimal number that's smaller than 1, the first non-zero digit is your first significant figure. In this case, it's 4. And then anything after that is also significant, including this 0, because it's between non-zero numbers. Now, 420, those are my 3 significant figures, but I also need to check whether I should round up. Should I round up or down here? We should round up because, so here, 7 is larger than 5, so round up. So my final answer is 0.0421. Again, when you do year 12, we expect you to know this. We don't have time to teach it again. So if you're unsure, please speak to me before the end of this lesson because there's very little time in the year 12 course for this. Put a star next to that. Okay, last one, scientific notation. Maybe I'll just do this one for you. So just a reminder, 0.1 is 10 to the minus 1. 0.01 is 10 to the minus 2. Hence, if I have 0.04, that's 4 by 10 to the minus 2. And if I want to add more digits, I add them to the decimal component after 4. Okay, so that's our answer there. Once you've got some experience, you can skip the first 3 lines. Okay, I will move on, but you'll get an electronic copy of this at the end. I'll upload it to Teams. So don't stress if you haven't got everything yet. All right, turn the page. We're looking at example 3 now. There were a few questions on the exam where our goal was to classify data. So I gave you some data and you have to tell me whether it was continuous, discrete, nominal, or ordinal. One of those 4 options. And this was not done very well. So let me start by saying that data can be either categorical or numerical. And some of you gave me categorical labels for numerical data. So we'll just be careful about that. So there's 2 types of categorical data. There's nominal and ordinal. With nominal data, there's no natural order to the categories. And with ordinal data, there's a natural order. Similarly, for numerical data, there's discrete data and there's continuous data. It's not easy to define the distinction between discrete and continuous. So for discrete data, what I wrote on your exams as feedback is only specific values are possible. Or it's counted. For continuous data, any value is possible. And in general, for those of you in science subjects, anything that requires a measurement, like time or distance or temperature, pressure, all of those things are continuous data. Okay, so now that I've given you that info, let's work through these 4 examples. The first one is the time taken to run the 100-meter sprint. This could be at the House Athletics or the Olympics. First of all, is this categorical or numerical? It's numerical? Yeah, there's no category here. And now the critical question, is it discrete or continuous?
Continuous,
Why?
because it's a measurement. It's time.
So that's my sort of advice that I would give to you. If you're not sure, ask yourself, is the data measured? And if it's measured, the answer is often going to be continuous. Country of birth.
Categorical.
And which type of categorical? Although you may have your favorite list of countries, there isn't a natural order to put the countries in that we will all agree on. So, yeah, nominal. For a rubric, base, medium, and high, we don't use rubrics in maths, but I imagine you use them in English and some of your other subjects. Clearly, there is a progression or order going from base to high. So this time the categories have a natural order, and that would make this ordinal data. And finally, on the exam, I gave a question involving money. Is that right? Yes, the price of the car, secondhand cars. So you pay money in dollars and cents, which means only very specific values are possible. I cannot have half a cent or 0.001 of a cent. So even though money has decimals, and decimals are often used for continuous data, money is one of the few cases where a decimal can give you discrete data. Okay? And Vika has asked that on an exam in the past, so they were expected to know that it's discrete data. Okay, can I move on? Okay, normal distribution. A lot of people left this question blank on the exam. So let's draw a picture. So in the middle, my mean is 60, and the standard deviation is a number telling me how spread out the data is. So what I'm going to do is I'm going to go up by 12 to the right, and I'm going to go down by 12 on the left. Down here, I'm going to write another number, saying the number of standard deviations, the blue numbers are above the mean. So in the middle, I'm on the mean. I am not above or below the mean, so I'm going to say that's 0 standard deviations above the mean. Standard deviation is 12. So if I go up by 12, I am 1 standard deviation above the mean. 84, 2 standard deviations. 96, 3 standard deviations. Here, at 48, I'm below the mean. So I can't say I'm 1 standard deviation above the mean, but another way I can express this is to use the number -1, -2, and -3. Okay, now I'll ask the class, what rule can we use here? There's a name given to the rule.
68, 95, and
That's it.
9.7.
Yeah, and those are the numbers. So this question is all about the 68, 95, 99.7% rule. Because you have a bound reference, you don't have to memorize those numbers. But if you do enough questions, you just end up memorizing them. So the rule says 68% will lie between -1 and 1. 95% will lie between -2 and 2. 99.7% will lie between -3 and 3. Even if I change the mean and the standard deviation. So once you've drawn the diagram and you've got all of this in place, this is a very straightforward question. The answers are just 68, 95, and 99.7. I can only use those numbers. If I change the numbers to say 50 and 70, I can't answer the question anymore because they won't fit with the 68, 95, and 99.7. So even though most students find this challenging, only a very limited range of questions can be asked because these are the only numbers we can play with, 68, 95, and 99.7. All right. Does that make sense? It's actually the biggest amount of work is actually in setting up this diagram here. Once you set up the diagram, it's very easy to answer the question. So you'll have some opportunities to practice it more next year, maybe Head Start as well. All right, turn the page. This is the last page. Okay. Rules of arithmetic and geometric sequences. It was a pretty horrible experience marking this because very few people got this. But I want to hopefully show you that this is a very doable question. So let's start by looking at the arithmetic sequence. The first two are arithmetic. So the information that I've given you in the table is that's probably the main obstacle here. If we don't know what the table means, we can't use the information. And this was given to you in the formula sheet. So what this is saying is if I start my sequence at A and then plus D every single time, like we do in an arithmetic sequence, then instead of writing out every single term, because that's a big pain, what I can do is write down a formula for the nth term, which says start at A and then add n times D. So all we need to do in this question is identify these numbers A and D and then chuck them into the rule. So replace them. So maybe with some audience participation, Abby, can you tell me what is the value of A in this first sequence? Yeah. Jet, what's the value of D? Okay. Ruby, can you give us the rule, please? Great. N times 4, 4 times n, 4n, they're all the same, and I accepted all three responses. All right. Carl, can you tell me the value of A here? Yeah. Aramia, what's the value of D here? Great. And Casey, what is the rule?
Vn equals 25 plus Vn plus 1, then minus 2. What was the representation?
So we're up to here.
Plus n times negative 12.
That's it.
Yes, so.
That's it. 25 plus n times negative 12. And we don't often write it like this. It's more common to write it like that. Minus 12 times n. Take 12n. So from memory, only 3 or 4 students in the class answered a question like this correctly, which is quite similar to last year. So I know it's challenging, but I'm hoping that now that I'm showing it to you, it's actually not that bad. You just got to know what to do. All right, last one. This is a geometric sequence, which means we cannot use the first row now. It's a different kind of sequence. This time we're starting at A and we have a common ratio, capital R. That's the number that we are multiplying by each time. So here, A is still 25 and capital R equals 4. And now I need to use this rule for Vn. So now it's going to be 25 times 4 to the power of n. With the recursion topic being challenging for most of you, you will go over all of it next year, but only in the space of about 2 weeks. And then there's another few weeks of new content. So think what I'll try to do is give you the occasional quiz with content from earlier in the year, just so that you don't forget it. We'll see whether that works. Okay, last example. The depreciation question was left blank by most of the class. So I don't know if that's because you ran out of time or because you just didn't know how to do it. So there was a lot we could cover from the finance section, but I think depreciation covers most of the class as in terms of something that we can all work on. So first thing is depreciation was a new word for most of you. Um, what does the word depreciation mean? Yeah. So some of you told me that the value was going up. You gave me an arithmetic sequence of a positive common difference d. That makes no sense. Your value should be going down over time. So you can't give me a car worth more than 25K in this question if it's depreciating. Okay, here we are told the depreciation rate is 5%. So I might say, to avoid confusion, I will not use R here. I'll just say 5 over 100 times 25,000. That's 1250. When we're dealing with flat rate depreciation, this means the depreciation amount is the same each time period. In this case, the time period is a year, so I'll just say the depreciation amount is the same each year. And that means every year the value of the car is going to go down by 1250. I don't have to recalculate it again after the second year. That would be the reducing balance depreciation method. So here, start at 25,000, go down by 1250 each year. So we actually want to use an arithmetic sequence, a sequence that involves adding or subtracting the same number each time. Here, my starting value is 25K. And every time I go to the next time value, an plus 1, I take the previous value, an, and I take away 1250. Don't want to add here because depreciation means the value is going down. Okay, and the last question before we finish up for the exam review. The rate of depreciation is 5% per year, but now we're using a different method. We're using the reducing balance method. And that means this time we're going to use a geometric sequence. Geometric means I'm multiplying by the same number each time. The crucial question is, what ratio should we use? What number should I multiply by each time? Open to the floor. You all knew it a couple of weeks ago. So I'm going to decrease a number by 5%. That's the same as multiplying by what number? So my common ratio, that is the number that I'm multiplying by each time, is 0.95. Hopefully you can see that 95 plus 5 is 100, and that's why 90.95 corresponds to decreasing by 5%. So this time, my starting value is 25,000, and whenever I go forward in time, I will take my previous value, Bm, and multiply it by 0.95. If you've got your exam paper with you, now's the chance, if you want to ask me to go do anything else, or if you want me to explain anything again from this handout, now's the time to ask. Otherwise, we'll move on to matrix multiplication. All right, thank you. We'll wrap it up there. Just give me 1 minute to set up for the next video.